So, what could a rover on Mars and your little robotic vacuum possibly have in common? Well, a lot more than you might think. Today, we're going to break down the 5 fundamental pillars, the actual blueprint that every single robot is built on. Okay, let's just dive right in. Have you ever looked at a really complex machine, like a giant factory arm or one of those humanoid robots, and just wondered what is really going on in there? Well, here's the wild part. It doesn't matter if it's a simple little vacuum cleaner or a super sophisticated robot. They are all built on a foundation of just 5 core principles. That's it, just 5. And these 5 pillars are exactly what we're going to explore. Once you get these, you'll basically have the blueprint to understand and deconstruct any robot you see out there. So here's our game plan. We'll start by looking inside the modern robot. Then we'll cover how they sense and act. After that, we'll get into the robot's brain, figure out what gives them power and purpose, and finally, we'll see how the whole thing comes together. All right, let's get into it. Section 1, inside the modern robot. This is where we start to peel back all that complexity. It's so easy to look at a robot and feel like it's just overwhelmingly complicated. But as this quote points out, they're really just systems of different elements working together. And our goal today is to pull those very elements apart. So let's move on to our first 2 pillars. Section 2 is all about sensing and acting. The easiest way to think about this is as the senses and the muscles of a robot. First up, we have sensors. So what are they? Well, simply put, these are the parts that give a robot awareness. They are quite literally the robot's senses, allowing it to perceive the world around it by collecting data. And this is where it gets really cool. A robotic vacuum cleaner uses infrared sensors to feel its way around a room and, more importantly, to not fall down the stairs. An autonomous car uses vision sensors, cameras really, to see traffic lights and pedestrians. And a delicate robotic hand uses tactile sensors to touch and pick up an egg without crushing it. It's all about gathering information. So if sensors are for taking information in, then actuators are for putting action out. These are the components that actually create movement. They are the robot's muscles, converting some form of energy into physical motion. And you see these everywhere in all different strengths. Electric motors give factory arms their speed and incredible precision. Then you have huge construction bots that use hydraulic actuators for raw, brute force power. And on the complete other end of the spectrum, surgical robots use pneumatic actuators for movements so fine and steady that no human hand could ever match them. So the crucial thing to remember here is this simple difference. Sensors provide the input, that's perception, gathering data. Actuators provide the output, that's the action, the physical interaction. One gathers info, the other does something with it. Which, of course, brings us to the connection between the two. Section 3, the robot's brain. This is all about how a robot actually thinks. At the heart of every single robot is its control system. This is the brain, where all the magic really happens. It takes all the data streaming in from the sensors, processes it according to its programming, and then makes a decision. And these brains can have wildly different jobs. The Mars rover's control system has to make autonomous decisions to navigate a totally alien world. Pepper the humanoid has a brain specifically designed to interpret human speech and even our emotions. And in a factory, one central control system acts like a conductor, coordinating a whole orchestra of robotic arms working together. And all of this boils down to one fundamental loop that every robot follows. It's called the core robotic loop. First, it senses the world. Second, it thinks about what that data means. And third, it acts by sending instructions to its muscles. Sense, think, act. That's the cycle, running over and over and over. Okay, so we've got senses, muscles, and a brain. What are we missing? Well, that brings us to section 4, power and purpose. This covers the energy and the tools of a robot. A robot is pretty much useless without energy, right? And as this table shows, the power source is always picked specifically for the job. A mobile drone needs light, portable batteries. A huge factory arm that never moves, you just plug it into the wall for continuous power. And a space probe, millions of miles from the nearest outlet, has to rely on solar panels. The mission always dictates the power source. And that brings us to our 5th and final pillar, end effectors. Now, if the actuators are the muscles in the arm, the end effector is the hand at the end of it. It's the specialized tool that lets the robot actually do its specific job. And this is what truly defines what a robot is. A robot on a car assembly line isn't just an arm. It's a welder because its end effector is a welding torch. In the same way, a medical robot becomes a surgeon because its end effectors are scalpels and clamps. The tool defines the robot's entire purpose. So let's put this all together. Section 5, the complete robotic blueprint. Now, the key takeaway here is that none of these pillars can work in isolation. A robot is a symphony. The control system is useless without data from the sensors, and the actuators can't do a thing without instructions from the brain. From the moment it senses something to the moment it acts, all 5 pillars have to work in perfect concert. So here it is, your blueprint for understanding any robot. The sensors are its senses, the actuators are its muscles, the control system is the brain, the power supply is its energy, and the end effectors are its hands or its tools. Once you start looking for these 5 parts, you can deconstruct any robot you encounter. So now you have the blueprint, you have the fundamental language of robotics. The only real question left is, what should we build next?